Hello, my name is Dereck. I'm the Division Chief of the Public Safety Communications Research Division at NIST, underneath the Communications Technology Laboratory. I'm very pleased to be here. I appreciate the invitation to speak to you today. My plan is to give you an overview of our program. I'm very excited to share the details of what we've been working on and hopefully get you interested enough to want to help us and join us and be a part of our efforts moving forward. So with that, I'm going to move in to give people a little bit of a perspective of where we sit as an organization within the federal government. So the National Institute of Standards and Technology falls under the Department of Commerce, and NIST is the nation's measurements lab that keeps the nation's time. The atomic clock is in Boulder, Colorado, where our labs are located. And so NIST serves the purpose of the nation's measurement laboratory to ensure open trade and weights and measures are kept for the United States. Under NIST, one of the laboratories is the Communications Technology Lab. It's actually the newest lab established at NIST, based on the knowledge and importance of communications to the nation's economy and security. And the first division established under the new CTL was the Public Safety Communications Research Division. Now, this program's been around for decades. However, the realization of its importance and the importance of the topic made it be the first division established under this newly created laboratory. Now, many people ask us what's our relationship with FirstNet, and just so you know, we work incredibly closely with FirstNet. FirstNet is a sister organization that falls under the National Telecommunications and Information Administration. Now, NIST and NTIA are sister organizations within the Department of Commerce at similar levels, and under NTIA is FirstNet. And so we are not in the same chains under the Department of Commerce. However, FirstNet staff and PCSR staff work hand in hand, looking at future research, sharing ideas, supporting each other's activities. So we are a very close-knit community. Just for your knowledge, FirstNet's CTO offices are actually located out here in Boulder, Colorado as well. So they're only a 10-minute drive from our laboratories. So we literally work very closely together. And in fact, I'll be talking a little later about how we actually share resources and space in our joint research activities. So who is the PSCR and what do we focus on? I've been at the PSCR now for almost 2 decades, leading this program, and the entire time our mission hasn't changed, and that is to serve as an objective technical expert on behalf of public safety. Public safety agencies don't typically have access to engineers and scientists that can help define requirements, drive requirements into standards bodies, and then test to ensure that products are meeting those requirements and standards. That's our role. That's what we at PSCR take on as our mission, is to really serve as that objective technical advisor to public safety, working closely with industry and academia to drive public safety's needs into new products and capabilities. So early on in our program, our focus started out after 9/11 to be really around voice communications and dealing with the issues of interoperability that were apparent after 9/11 and then Katrina, and still sometimes crop up to this day, but to a much lesser degree. However, around 2007, 2008, it became apparent that policy was shifting to make available to public safety a broadband capability and network that would afford public safety the same kinds of next generation communications capabilities that commercial customers and consumers were using daily. And so we started to also shift our focus away from the legacy Lambo Radio issues and really start to focus on that future broadband next generation first responder and how they would utilize these capabilities and ensure that as these technologies were evolving, that they would take account of public safety's needs and requirements. And when I say public safety, just to make clear when I talk about it, our key focus area at PSCR, our stakeholders that we really see as the core of our program are fire, EMS, and police. That is who we are focused on. It's really about boots on the ground, on-scene response to emergencies and disasters. So that's who our core stakeholders are. Now today, what I'm going to be talking about is specifically what came about from the 2012 Middle Class Tax Relief and Job Creation Act that was passed. Now, most people know it because it was the piece of legislation that created FirstNet, which is an incredibly important evolution in public safety communications. And that same legislation, though, actually provided NIST with $300 million to support research and development to help public safety transition to broadband and take full advantage of those capabilities and help push new capabilities into the evolving broadband commercial space so that it would meet public safety's needs. So what we started doing back in 2013 after the legislation was passed, now unlike FirstNet, NIST didn't get access to the funds until the spectrum auctions were held and deposits were placed into the Treasury. So for us, we didn't actually get access to the $300 million until multiple points in 2016. We didn't have the full amount until the beginning of 2017. But up until that point, we started immediately working on roadmaps, trying to understand the key priorities that we should focus on. We understood the importance of this once-in-a-lifetime opportunity to really make a difference for public safety in this broadband future. So we started gathering stakeholders from FirstNet, public safety, academia, industry, other federal agencies, and working hard to identify what the key areas of focus would be, and I'll go over those in just a minute with you. Now, we received a lot of money, $300 million, one of the largest influx of R&D funds for public safety specific communications research in history. And so we wanted to ensure that we were able to carry this out effectively. So we had to create a strategy by which we could undertake this and achieve our goals. Now, I talked about that we had to wait to get the money until the spectrum auctions occurred, so we didn't really get to launch the program until 2017. Unfortunately, the legislation also came with a stipulation that all the money had to be spent by September 30th, 2022. So we had a very narrow runway for an R&D, an aggressive R&D program to get a lot done in a short period of time. So we knew we weren't going to do that all internally. So we built a program really based around three prongs. One, leveraging the internal expertise of NIST. And so we have about 100 scientists inside of NIST across the laboratories focused on public safety specific research, oftentimes around measurement science and how to measure the kind of things that we are focused on to ensure that we can accurately depict the capabilities being developed for public safety and measure the success against public safety's requirements. But we also realized we weren't going to do this all on our own. So we created an external research program through grants and cooperative agreements and have created significant numbers of relationships with industry and academia around the world to help us do this. In addition, we created a very innovative prize and challenge program that tries to leverage and engage with very non-traditional entities that normally wouldn't be involved in this kind of funded research with the federal government. So I'm going to take a little bit of time and just talk about what we mean by open innovation and prize challenges real fast so that you understand this, which is open innovation is really kind of flipping the traditional method of funding through the federal government on its head. So typically through a grant or a contract, we come up with a statement of work and a requirements document. We put that out for bid. We get a number of bids off of that, and we determine which one we think is going to best meet our needs. We fund it, and they go off and try to achieve those goals, and they either achieve them or they don't, but it's all based on the initial assessment of whatever they stated they would do over a period of time. The open innovation model flips that on its head and says, here are our goals, here's what we want to achieve, and we are looking for anybody to actually come up with an innovative approach and prototype that would do that. And all contestants are open, regardless of your experience, regardless of your history, regardless of your resume. If you have a great idea, you can build it, you can enter it into the contest, and the winners are determined on how they actually operate and perform, not based on whether or not they had the right credentials or resume up front. So it really allows for a whole different pool of participants in our research that normally wouldn't be involved, like high school teams or college teams of innovators, or people who just may be hobbyists in a specific field that really want to get involved, that normally wouldn't be able to win a grant or a contract. So through this model, we've been able to interact with hosts of innovators that are very, very different and non-traditional from the typical types of entities we would engage with through grants and contracts. So those are the three prongs of how we've approached our program and how we are leveraging expertise not only within this but across the world to get what we need to get done in a short period of time. Now, I spoke about earlier the fact that we started in 2013 sitting down with our stakeholders and identifying the key areas that would have the largest impact on public safety. And so now what I'm going to walk you through are those key areas, and I'm going to eventually talk about some of the highlights of them. But just briefly, before we dive into each, to give you a high-level overview, what we identified as the areas that we would focus on with the $300 million over the period of time that we had access to it was mission-critical voice, linking Lambo Radio to an LTE network for the period of time that those two networks coexist, enhancing the user interface to the network and through their devices so that it actually meets their operational requirements, enhanced location-based services, especially in building, public safety analytics, so ensuring that they have a way to make use of the increased amount of data that would be flowing over these broadband networks. And then we had a couple of cross-cutting areas that were identified that really applied to all of the portfolios I just talked about. One is security. We want to ensure that the information being passed over these networks is secure and that access to the network is secure so that only the right people are getting access to the right information. And then resiliency. All of these features are important, whether or not the macro network is available. So we want to look for ways to ensure that they can get access to all of these features and functionalities, whether or not they're in the middle of a fully covered urban area or out in the middle of Colorado with no cell coverage, responding to a wildfire, but expecting and needing these same capabilities. So those are our key areas, and now I'm going to walk through in a little bit more detail about what we're looking at and talk about some highlights. First of all is mission critical voice, one of the most important portfolios we have, and that is public safety has key features and functionalities on their Lambo radios that they've used for decades that are critical to their operations. And really we define mission critical voice as mission critical push to talk, efficient group communications, and direct mode communications. And that's kind of the key unique features that aren't typically found in commercial products that are absolutely imperative to public safety and their operations. Now, what we took on as one of our primary goals internally at NIST to do in the mission critical voice space was to come up with a measurement system that would allow us to quantify and measure mission critical voice. That didn't exist when this all happened, and people were talking about whether or not public safety could use broadband for mission critical voice like they used Lambo Radio. And the first thing we had to do is get public safety together and say, what is mission critical voice? What is the definition? And how would we turn that into a measurement system where you could compare technologies from Lambo Radio to LTE to 5G, 6G, and beyond, regardless of what the technology is? How do we look at mission critical voice delivery? And so what they sat down and they did is with public safety, we really came to this measurement system that would focus around the user experience, not just network parameters and indicators inside of the system itself, but looking at how does the user experience the communications and the system. And that came down to some elements like voice quality and speech intelligibility. Can they understand it at the end of the transmission? Did they get what they were supposed to get? Mouth-to-ear latency. How long does it take from the time the button is pushed and speech is inserted into the system to get to the listener? End-to-end access time. How long does it take from that push of a button all the way to the end of the delivery? And then the probability of success. When I hit that button, what's the probability that I'm actually going to get access to the system and maintain it throughout the transmission? So those were the things that public safety helped us define as the key elements of mission critical voice. And now we've spent the last several years creating a measurement system that would break these parts, pieces of the definition apart, and allow a public safety agency or researchers or a company to start to quantify and measure and compare different systems across these parameters. And as you can see at the bottom of the slide, we have a host of publications that go into detail about all of these issues. We have data sets available for research purposes, and what we're hoping is this becomes a measurement system that will help people understand the differences and implementations of mission critical voice across technologies. So next, what we're going to move to is Lambo Radio to LTE. So the ability to cross-connect the two systems while they coexist. And really, our core areas of focus in these in this is monitoring and providing input into the standards that would connect things like Project 25 standardized LMR systems to 3GPP LTE systems. We are attending and chairing working groups in this space and working on software-defined radio applications where we can move beyond the donor radio model that exists in many areas and allow cross-connection across systems without donor radios, and potentially allowing greater feature functionality across systems. Next, what we're going to go into is the user interface, user experience portfolio. And that one really is looking at ways in which to change the way the user interfaces with the system. Their first iterations of next generation devices are pretty much the same commercial devices we all carry around today. Smartphones where you pinch, you zoom, you scroll, that's a fantastic additional tool for public safety. But interacting with them in that way does not meet a lot of public safety's use cases, like trying to utilize a map for a firefighter when inside of a burning building. They can't see the screen, they can't interact with it because of the gloves, or a SWAT team member can't interact with the phone when their hands are full of a rifle. So we really want to re-envision how public safety would provide information to the system and receive information from the system. And areas we're looking at are usability requirements by doing thousands of interviews with public safety to understand their usability needs. We're doing research into testing methodologies and how you'd apply those to understanding public safety's needs for user interfaces and which user interfaces actually make the largest difference to their operational objectives. And then we're looking at specific technologies like augmented reality to understand how augmented reality technologies, as they evolve, will be useful to display and project information to public safety in their various environments, and how much that will help them actually carry out their operations. And then we're exploring virtual reality so that we can find ways to place public safety into a familiar environment and yet make it a repeatable and controllable environment so that we can test out different user interfaces and understand the impact of each of those interfaces on common objectives. And so one of the areas that we've worked on that we are actually building out right now is a large-scale user experience center leveraging space provided to us by FirstNet in Boulder, in which we have a large, almost 40 by 40 space, 40 foot by 40 space with millimeter accurate virtual reality systems capabilities, so that we can highly accurately track people and objects inside of that space. And we have wall systems where we can recreate building types and environments, and then place public safety in those environments, have them walk through familiar scenarios and undertake tasks, and lay in front of them any kind of user interface we can imagine: heads-up displays, haptic feedback, audio cues, and understand which one of those help them actually obtain those objectives more effectively. And in the next slide, what you'll see is actually a current project of ours internally to create a highly realistic warehouse environment that we will be able to place inside of that FirstNet Experience Center, so that you would be able to actually enter this warehouse environment in virtual reality, explore it, walk around it, touch walls, and when you reach out and touch a wall in virtual reality, you touch a wall in that space as well. We can create fires in this space. We can create active shooter situations, EMS emergencies, and this can become a very realistic environment that public safety can, that we can use to test public safety in. That's controllable, repeatable, but familiar, and actually will allow them to attempt tasks that are familiar to them in their normal job situations. So this is an area we're very excited about and happy to be working closely with FirstNet on. So the next area that we'll talk about is location-based services. And again, as I said in the beginning, we really are talking about in-building location, and here we really have three areas of focus for this portfolio. One is getting an accurate map of the building that you're responding to. The second is tracking inside of the building. So we're talking about tracking on the XYZ axes and a sub-meter resolution, so highly accurate tracking indoors. And then once you have that map and you have the tracking capability, how do you turn that into a smart navigational system that allows a user to get from A to B and back to A if necessary during an event? So we really are looking all three of these as key areas of success for this portfolio. And another aspect of this is that we really expect this to be a capability that requires no pre-existing infrastructure in the building. We want it to be something that can be deployed at a 100-year-old warehouse or a brand new smart building, and not require that brand new smart building to be able to be a functional capability. So one of the things we're doing on the mapping side that I'll give you some information on is we're exploring the use of LiDAR for in-building mapping so that public safety can keep and maintain and create on their own highly accurate maps of the buildings that they would be responding to. And we're using a LiDAR backpack. Here you see the head of the LiDAR system that would be sticking out of the back of the backpack that we would wear to walk around a building and map that building in real time. And to see what we can do with this, actually, in the next series, you'll actually see a video that we created using this backpack that is our building in Boulder. And this is actually something that we recorded at this level of detail of our building. And it took as long for us to get this information as that took for us to just walk through the building. So it is not a user-intensive effort. We literally just walked through the building at a normal pace and walked through the rooms. And when we were done, we had a fully rendered 3D, what you would consider dollhouse view of the entire building. And so what we're exploring is, is this the kind of technology that at some point public safety, a fire marshal or somebody like that, when doing other jobs inside of buildings, could be wearing this type of technology and walking through those buildings and just mapping those buildings in real time and being able to take those maps back and make them available to the entire public safety agency organizations in that area. And an important element of these types of technologies is they also have change detection. So if you walk through the building one year in an inspection and there was an empty hallway, and you walk through the next year and there was a wall that cut that hallway, your system would actually tell you that this was not here last year, and highlight to you any changes that it detects. We're also looking at object detection capabilities so that as the buildings were traversed, that the system itself would identify things like sprinklers or fire alarm pulls or any objects that are important to public safety, and that would require no effort on the part of the person walking. They could focus on other things, but the system would be collecting all of that information and mapping it in a highly detailed and accurate method. These are sub-meter resolution capabilities, and mapping those onto this very accurate 3D map. So this is an exciting space that we're working on and looking at applying to public safety use cases. So we'll move on now to public safety analytics, and this is where I was talking about ensuring that public safety could make use of the large amounts of sensor data, database information that would be available through this broadband system, and provide it to them in a way that they can consume and operationalize. So we're looking at things like social media analytics, video analytics, and then data de-identification. So how do you take advantage of all of this information that might be available that could be potentially highly sensitive, and yet allow it to be used for analytics for looking at trends or making observations about potential futures, however, while ensuring that individuals' privacy is maintained. So one of the key programs we've been running through prize challenges, using that prize challenge model, is a data de-identification program looking for algorithms that will de-identify large data sets that could be used to detect trends and future possible issues, while ensuring that no single person can be identified from that data. And an example of the kind of data sets we're looking at and considering is, in this case, in the map on the right, you see that this is a taxi map from, I believe, New York City, and the whole idea is just based on time and place information from the information gathered on taxi rides, it would be possible to actually identify a specific individual as that data is collected over a period of time. And so you can imagine you wouldn't want that kind of information available, and you wouldn't want somebody to be able to use that information. However, you could also imagine that kind of information to be useful for large-scale analytics and trends. And so you'd want to have access to the data set, but you wouldn't want to have it be able to actually predict an individual's identity. So we use data sets like this to have people create algorithms that go in and they scrub the data set from a perspective of making micro changes to some of the data, so that it maintains its integrity from a analytics point of view, and yet changes the information enough so that no person is identifiable from the data. And this is really cutting edge research that's gotten the attention of even the Census Bureau. And what we hope is that things like mapping data, time-stamped data, information from databases will be able to be leveraged for enhanced analytics, and yet also maintain secure de-identification of individuals, so that people don't have to worry about their personal identification and personal information. So from here, we're going to move on to those cross-cutting areas that I was talking about. In security, we are really looking at some focal points of mobile single sign-on, mobile application security vetting, so ensuring that the applications you might place on your first responder device don't put the whole device or system in jeopardy because of security flaws. We're looking at handsets and wearables, but one of the key areas we're looking at is identity credentialing and access management, otherwise known as ICANN. And so in the ICAM space, which we really think is imperative, you want to make sure that when somebody has access to the system through their device, that they are the right person, that they get access to only the information they should have access to. But you also want to ensure that you do it in a way in which it gives them efficient access to the system. That, a public safety user can't enter in a 25-key security pin every time they need to access the system, because they may be doing something that is very time sensitive. So it needs to be a safe, secure method to get access to only what they should have access to. So we're looking at things like federated identities, biometric authentication, continuous multi-factor authentication. So maybe you access the system initially by entering in a passcode along with a secondary type of identifier, or maybe a biometric authentication identifier. But over time, it would keep you logged into the system if it continued to monitor certain things about you, that could be things like your walking gait, or whether or not if you have a smartwatch on, and that smartwatch stays within a certain range of your device throughout throughout that time period, but if it gets too far away, it would lock your device. Things like that, taking into account the various ways that public safety could maintain access to the system, but also know that under certain circumstances it would shut down access to the system if continuous multi-factor authentication wasn't maintained. We're also looking at identity as a service for public safety and cloud security. And then finally, in the area of resiliency, in this space, we're looking at issues such as edge networking and edge computing. We're looking at mesh radio technology, and we've been looking several years at deployables and how deployables could help improve the capability of public safety to maintain operations in remote areas or in areas where their macro system is down. And so an example of this work has been a series of drone challenges we've ran over the last several years, looking at whether or not a affordable sub $20,000 drone could be developed that would be able to fly a 10-pound package that mimics the weight of what a standalone LTE network would weigh, that would be able to support, say, up to 100 to 200 users at a event site in a remote area, and be able to fly for a period of time to support that site with a standalone LTE network. When we ran the first challenge in this space, it had requirements of sub $20,000 build. It had to meet FAA guidelines of less than 55 pounds. It had to fit in the back of a pickup truck. This was a tall order because those kind of drones just didn't exist. And the longest flight time we had at that time, that first challenge, was 18 minutes with that 10-pound weight. We just reran that challenge. We took lessons learned from it, had pretty much the exact same parameters going into the second challenge, and we saw teams increase from 18-minute flight time to almost a 2-hour flight time. So we saw significant gains in a matter of 18 months to 24 months of what a drone like this could do. And when you're talking about a 2-hour flight time, that actually becomes a viable communications platform that could be deployed in very difficult terrains and situations for public safety. So we were excited about these outcomes. So then what we'll move into next is our commercialization space. And in the commercialization space, I've talked about a lot of what we've done to date that's specific to focusing on research and development that would support public safety, and getting a lot of those ideas out from internal research, from grants and cooperative agreements, and from prize challenges. But we don't want to stop at just helping start and creating a space for this research and development. What we wanted to do is actually get these research ideas, these prototypes, into the hands of public safety. And so we created an entire space inside of our program focused on commercializing these ideas, and we've done it through 3 different areas. One is we created a grant program that creates the capability of people getting funds to help build a business plan for their idea, as well as receive funds to do a pilot demonstration with a public safety agency to get direct feedback on their technologies so that they can make improvements and create a better viable product. We've also created a Pulse Accelerator program, which is a 12-week course for people who apply and are accepted that put them through an intense 12-week session of how to create business plans, how to create a business. They interact with industry experts as well as public safety to get feedback on how to move forward and actually take their product to market. And then we've worked with FirstNet and the Economic Development Administration, or EDA, to create an R2 network, which is really what you could think of it as LinkedIn for public safety. And it brings together public safety agencies with new innovators, industry, academia into a single space to talk about public safety's needs and to link public safety to people who may be producing or creating products that could meet those needs, and hopefully create a shared space linking everybody together so that they can work together on these very important topics moving forward. To give you an idea on the impact on these programs and what we're thinking of when we talk about commercialization, just to give you some ideas, we've done $76 million in grants to date to over 179 award recipients. So we're talking about almost 180 research prototypes being developed over this period of time in just the last 5 years. We've had 1 patent granted from those grantees to date. 3 additional ones have submitted patents, and a number of these recipients have actually created open source tools and data sets and software that's available for anybody to use in their research or in future potential products. That's just on the grant side. On the prize challenge side, we've launched 14 prize challenges with 176 winning teams, each team having to have provided a prototype that won based on the elements of the prize challenge. We've awarded over $3.6 million in prizes to date, and we've received over 745 total submissions from teams. So we have an entire new space of innovators and people interested in this public safety space that weren't involved in it before, which is very exciting. And so we have a lot of fertile ground here when we're trying to apply that commercialization philosophy to these efforts, because there's a lot of great ideas that come out of these challenges and grants, and we're hoping that our commercialization efforts will allow some of these teams to actually turn into a successful business and get their products into the hands of public safety for use. Now, some current opportunities I just wanted to make you aware of as we near the end of the presentation is that we do have some ongoing opportunities. We have a current prize challenge focused around mobile fingerprint capture. So looking at the possibilities of public safety being able to use their broadband devices to capture fingerprints in the field successfully. We have a third first responder drone challenge, the UAS triple challenge, that is happening right now and is still open to walk-ons. And then we're about to have a final grant program under the $300 million that'll probably be announced sometime mid-November. And it will cover a number of our research areas that I've talked about today. So then finally, my call to action to you is we would love for you to get involved. I would love to have your participation in our program, and there's a number of ways to do that. First of all, I want to invite you into our lab. We've recently recorded a virtual lab tour of our space. You can walk through our lab in Boulder, and while you walk through, you can stop and get demonstrations in the various portfolios that I've talked about from the experts in our program. I've made this virtual lab tour available to the conference, and if you haven't already gotten access to that link, please just reach out to the conference provider, and hopefully they can make that available to you. And if you need additional information, just let us know and we can get it to you ourselves. So how to get involved? Step one, we have a mailing list that will get you access to our monthly newsletter, and that newsletter will make you aware of any information that's being released, any new funding opportunities, any meeting opportunities that may be coming up in the near future. So I encourage you to sign up for that mailing list, because through it you will get a host of information that you could either use yourself or you might want to pass on to people you think would be interested. Also, we have a website, pscr.gov, that has a lot of information that I've gone over today in far more depth, as well as all of our previous conferences with all the conference materials and videos. If you want to dive into any of our projects, we have hundreds of hours of material and video on our website that can keep you entertained. And then finally, we're always looking for help. So we run prize challenges, we do grant reviews, we need subject matter experts, we need judges. So if you're somebody who would be excited about participating in some of these activities in the role of a judge or a subject matter expert, please let us know. And we're always looking to increase our list of names so that we can choose from that list in the future. And we'd love to have you, and we appreciate your interest in this. So with that, I'm going to wrap up my talk. I appreciate your time and your letting me come and speak to you today. And hopefully in the future, we'll be able to do this in person. And otherwise now, I'm going to make myself available to questions. So thank you very much and take care.
So Dereck, are you online with us?
I am.
Dereck, unfortunately, used all 45 minutes. So we have no room for Q&A.
All right. Well, I thought
so,
okay, sounds good. All right.
So
well,
you're
any questions you might have. That was an easy Saturday afternoon. Very good.
Fabulous presentation. And can people contact you directly at pscr.gov?
Of course. Yes, absolutely. We have a email on the website. You can contact us. You can get a hold of me. Anything you need, and like I said, that virtual tour, I gave that to John Pscr, and he can distribute. We were hoping to have you on site. If you guys were in Colorado, you were going to ship some people out to our site. That wasn't able to happen, but maybe in the future that can happen, because we put on a good show.
Well, let's put that on the docket here in the future. But a tremendous presentation. If you have questions for Dereck, it's pscr.gov.